Hi all. Today we are going to see how we can integrate one machine learning model into a web application. So what the things we are going to do here is first we'll be creating one machine learning model given a data set. We'll build our machine learning model. Uh, Basically, we'll train our model using Python. There are different modules available in Python. We'll use the scikit-learn module and we'll create one linear regression model. Okay. Then we'll save the model. Okay, and we'll create one web application. With the web application, we're going to integrate that trained model actually. And then we'll demonstrate the model prediction into the website. The web browser will do that. And after that, we'll learn the mathematical mechanism inside the model. How the model is learning from the data set. Given a data set, it is generalizing the data, creating the model. How these things are happening. Okay. Mathematics will learn. And we'll do the code from scratch. Basically, will be not using the scikit-learn module. Our own module will create it for understanding the mathematics. And then we'll comprise, do the comparison. We'll do the comparison with the scikit-learn module model and our own model. And we'll see both are exactly same. So these are the things we are going to do now today. Okay. Now let's learn the workflow through this flowchart. So it will be easy. So first what we'll do, we are going to do load the data set, basically collect the data set first, training data set. Then from the data set, we'll create our machine learning model and then we'll save that model, pickle file, and we'll create our web application Flux API basically. And we'll integrate this model with this API. Then create one URL that basically front end, see in the front end website how the model is performing tasks. So final result will be something like this. So we'll provide some input here, then we'll click the prediction button and we'll see the result. It will predict. So basically in the first, at first we'll do the coding. Okay, we'll see how we can integrate the model, how we can create the model and we can use that model. And in the second part, we'll learn the mathematics. Okay, start coding part. This is our data set. The data set is uh, given the year of experience, predict the salary. This is the data set. Simple data set. One column only and one target. Feature column is one and one target. So we'll basically do the simple linear regression. Okay. Only 30 rows there. So let's start the coding section. Okay. First we'll create one IPython file. Here first we'll load the let's first task is to load the data, then create the model. Import The loading is successful. Now see the data, visualize the data, okay, the data points. Let's plot the data. Put that, put matplot the data. Here, data plot is X, salary will be Y axis. Data of X axis. This is the data. It's almost linear data. So now our task is to fit one line, fit one line, regression line, okay, so that it can predict for the unknown values. Let's do that. So for that, we are going to put a scalar linear model, linear regression model. Oh, before that, we need to split the data set into train test. Okay, scalar model selection, model selection, test split. And we are going to perform the we are going to test how good is our model. sklearn.metrics, we are going to put R2 score. Square error is also fine, but we'll use X. Train X test 1, train Y test. Random state 0. You see that? Now, put a linear regression model that dot fit X train Y train. That's fine. And it's done. So, alert linear regression model is done. Now, let's see the line it will draw a line. The data set. Let's see plot that actually. T dot string and letter the line, the model. Take the score, R2 score, Y test and LR predictor text test. 98% accuracy. Okay, let's see the how it is doing for the test data. Plot, plot, plot the scatter X test. Uh, both will be scatter plot. Scatter. train also X test and the test, not the training data here done. The training data using the test data. Color, paint, label, label, actual data. Exactly this here, at this point, exactly it's predicting the accurate value. That's why it's coming. It's 98%. Okay, so we have this data. Now we have this model. Now, what we have to do? We have to save the model and create one web application and integrate uh, that part. Save it. Pickle. We'll use pickle. Save it as model.pickle. This name we're going to save it. Right. So now we can see there is no model.pickle file is there. Once we run this line cell, we'll create this pickle file. See that model.pickle file is ready. Okay. First part is first row is done. Now we'll create this Flux API and we'll integrate the model. Okay. This part. For that, let me create one folder. The name web app web page. Like that, first I have to create one Wi-Fi. Then module. From Flux. Both Flux render template are also request. Okay, we'll create the app first. Flux, Flux name. Okay. First, Flux is to load the model. For that, we need to import the pickle file. Equal to pickle dot load open read. But here we have to keep the path. Right here. Dot slash module. Cyan. error message. Now let's create the route, home page create. Here, that's actually we're going to create one form, and that form will get the post request. First, you will use the get and post also. Get index, anything you can name it. For that, text.html file, so base.html. That base.html extend one more folder static. Yeah, it will JS. Advanced CSS file. CSS file. Title, salary prediction, link, styles it, styles is link done by that type also. That's great. Oh, we are not having any minted jQuery or nothing. Yes, that's equal to URL static and script.json. That's correct. Script.js. Now, here, create one Darkspash blog content. Neat. Darkspash script. Salary prediction. Navigation bars. Apple. That revenue about extend that base.html. Yeah. Extend, extend. Title, blog title. Now we need to create one form. Form actually. Meeting the request through that form. So heading based on your input, not based on year of experience. Years of experience predict the salary. That level will be X input button to this form and click on submit. There will be post request will be done. Based on that, first what we need to do, we need to collect that form data and we need to pass the data into the model. And model will predict something, and that prediction we're going to send to the uh, website. Okay, URL. Okay, that we need. So we get one table called prediction. Prediction is none at first. Okay. Now, if the request method is equal to post, and also you can check for the model also. Model is none, and method is equal to post. Then what we are going to do, we are going to take the experience request dot form id is experience. Okay, value it will take. We'll pass that data to the model. Model will predict that data. Model dot predict. Okay, first this prediction going to set prediction. Yeah, prediction. Prediction of the model. Predict salary print. It's almost done. Now run this app. And you open the CV. First, we'll activate our virtual environment mode. Virtual environment VNP is activated. Now change our directory. This directory, web app directory. At that web app. Web. Ah. To run this app, then only it will run. We have written that code for run. Now, if name is equal to main, need to run that app.run. Now it will predict it. Now, if I provide -5 also, then also it will predict, but -5 is not a correct input for this. So we need to restrict that one. Also, if we provide T, then it will give some error. Okay. So these things we need to handle. Okay, let's do that part also. First thing we'll handle the error message. Okay. So here to use the try and accept. Try this one. Try this one. It's prediction. Wanted. The string file. Here, what we can do, we can restrict form submitting by providing one validation. Okay, so for that, one submit will run one validation. One submit will run one validation, form validation. Validate this one, then submit. Write down the code for that through JavaScript. Validate the form. What we need to do, we need to first get the element value actually. Document.get element by ID value. If the value is not number or less than 0, then we are going to restrict. Okay, so same thing. If alert, please enter a valid number for year of expense. Server is down. Server is down. See, now because last time we have entered the t value, so it's predicting for the t. Okay, this is also one bug actually. We need to fix this one also. We'll do that one. Now if it t, then it actually give you the home page. Now let's give some G string value. So it will not submit the form. Instead, it will show you the error message. One alert, not the error message. So you one alert message. Give the right input. Please enter a valid number for years of experience. Okay. Now if I give -5, then also because this is less than 0. Okay. Now if the actual value 3.2, predict, yeah, prediction is predict salaries. Okay. Now you see after clicking the predict button, the value what we have given here, right? That is removed. We need to keep that value also. For that, we need to do some changes. Let's do that also. Okay, let's go to the here give equal to experience. But this will be experience. Okay, so that value we need to send experience if experience else it will be a string. 3.2 predict 3.2 there and this should be your salary. Predicted salary is this much. So that's the thing how we can integrate the model. We've integrated the model with the web application and it is giving the this model we have integrated here. Here we have actually loading this model and using this model here model whatever the form value providing that form value we are passing it the prediction we are getting the prediction printing the prediction. That's now let's understand mathematics how it is doing these things. Okay, really what the model is doing, the model actually so you have the data set, these are the data you have, and for this data the model is actually drawing a line. Linear regression means drawing a line. Okay. For this line, you have given the unseen data, test data basically. So it will predict when this model is doing. So what we need to learn or we need to calculate the line equation of the line. We need to calculate for the given data x, y, some data given. This is the salary. Oh, x is the year of experience, and you have the salary. These are the data given x1, y1, x2, y2. The data given. From this data, you have to calculate this line equation. Y is equal to mx plus b. Okay. Now, how to calculate this line equation? Basically, we need to uh, fit the line so that the error, minimizing the error actually, this error will be minimized. So understand the mathematics actually. Task is to calculate y is equal to mx plus given x1, y1, x2, y2, xn, yn. Now, the predicted value m and x is given plus b. Each value is predicting the value. So our target is to minimize the error. Okay. Actual value and the predicted value. This value actually we want to minimize. This is your line. So this is your line that is predicted. Now these are the error points. This is the error. This is also error. This is also errors. Few errors. So if you calculate this D1, this is D2, this is D3, T4, T5. So our task is to minimize this error. Summation of Di. This Di is what is the actual value. So actual value is y, and the predicted value is y cap. Suppose. So Di basically you sum square. Okay, Di basically yi minus yi cap predicted value. Summation of yi minus yi cap whole square. This we have to minimize. Okay. Now we are considering y cap should be this mxi plus b. Considering that is actually a parabolic equation. Parabolic equation. And to find the global minima, what we need to do, we need to derivative it with respect to m and with respect to b also. Make it 0. So L equal L b first. I equal to 1 to n. I am the same x minus b. I is equal to 1 to n. So summation of yi minus m summation of xi minus n times dividing both by n. 0 or y bar, y mean basically. Um, and this will be x bar, x mean, and this will be n times b by divided by x, 0, or b is equal to y minus mx bar. What does that mean? That means if you have, that means you have this y value and have these x values. Okay, to calculate the mean of these x values, and you have to calculate the mean of these y values, and you have to calculate the m value. Okay, and then you need to calculate this expression to get the b value, right? Okay. Now, similarly, is equal sorry, equal this expression. whiteboard. Questions. What is equal to what is calculated p is equal to y bar m x bar. Here is equal to m x bar minus y bar plus m x bar. Right. Is equal to now square missing the square. Y bar m xi plus m x bar square. Now let's differentiate it with respect to m. Right. Plus m x bar plus m x bar square equal to 1 to 2 into this term yi minus y bar minus m xi plus m x bar into this part x bar minus xi. Right. Xi minus x or 0 del I minus y bar xi minus x bar equal to xi minus x whole square. Or the m is equal to switch I is equal to 1 to n xi minus x bar into yi minus y bar divided by xi minus x bar whole square summation. Final got m is equal to summation of yi minus y bar xi minus x bar divided by summation of xi minus x bar whole square, and your b is equal to y bar minus m into x bar. This is the result. What does that mean? You have given x1, y1, x2, y2 data you have given, so you have to calculate the mean value of this one that assigned to x bar. You have to calculate the mean value of y1 assigned to y bar. Okay, and then each yi you subtract that y bar mean, and then for each xi you subtract that x bar value, and multiply and do the summation for each I, and same thing, square it and divide it. It will give you m, and once you get the m, you can calculate the b, and once you have both, write the expression y is equal to mx plus b. That is your plot. That is the plot. So here the plot we have done this 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 line equation. Let me show you the intercept value, and this is actually we call it intercept. Called we call m value as coefficient and p as intercept. Okay, let me show you the intercept and coefficient value for the model. Taylor intercept. Okay, 6780 and Taylor dot coefficient is actually 931. Okay. Now the same thing we'll calculate from the scratch. So we have understood the mathematics. Okay. We can calculate m and b by our own. So let's calculate the m and b and let's compare that m and b with this value, whether it is exactly this value or not. From class initialize it, definition init, function. Then dot your intercept first coefficient. Then dot intercept third find the fit method, which train data set of x train basically x train and y train both from that calculate this intercept and coefficient value. First let it as array, it be as array, as array. Mean value x mean is equal to p dot mean extended and y mean. That's correct. Now we have to calculate the summation part. Summation part, this part. Now to calculate this part, yi minus y bar, xi minus x bar. Summation. Okay, that is np dot sum. Is one vector, and for all each vector we need to subtract this value and then multiply. Let's do that. Np dot sum. We have x train, correct? X train minus x mean, y train minus y mean, and then multiply this and then divide. P dot sum, same thing, x mean square. Numerator. Then coefficient. Y mean minus coefficient into coefficient x mean. Left intercept and coefficient. Now predict function x is value as added, then return sep dot y equal to mx plus b. So m into x plus y. So return y equal to mx m sep dot coefficient into mx, x is x test, correct, plus b intercept. Done. Yes, you have completed. And let's load the dataset again and let's do the train test split and call it. Data is equal to video trade CSV. Year of experience. Salary. Train test split. Second. Train. Simple error. Let it fit x train y train. It's done. Now let's see the coefficient. LR dot coefficient 9312. What's that? 9312. Same coefficient value by sklearn and our model. It's giving the same number 93125257512. 57512. Same. The intercept value will be also same. Also same. LR dot intercept 26780. 6780. 26780. Correct. Now let's check the R2 score for both. R2 score LR, okay, 988, say 0.988. This is yeah, this is how happening. Simple linear regression model. Okay, yeah, that's all. Thank you.